For this video, we will be talking about how to find one of the 6 trigonometric functions. For this, is asking us to find cosine of theta, which they give us sine of theta, which is 3 over 5, and also that theta is in the second quadrant. So for this, all we do is just draw x and y coordinate plane. You know that theta is in the second quadrant, so we could just randomly draw a line like this and bring it down all the way down to the x-axis, like this. Draw a right triangle over here, and then now we know that that area over here is sine over 3, 5. So we know that sine is equal to, in this case, 3 over 5. It's been given to us. When you're given sine, it is the same thing as y over r. Okay, so in this case, the y coordinate will be 3, the r coordinate will be 5. So in this case, 3 is y, so that means the y coordinate goes vertically, while the hypotenuse side, this side over here, will be 5, because that is r. We are trying to find cosine, which is x. That is x. Also, we can look that this side, the x coordinate side, is negative because it's in the x coordinate and negative side, so it'll be a negative number. So to find the missing side, all we do is use Pythagorean Theorem. So 3 squared plus b squared equals 5 squared. 3 squared is 9 plus b squared equal to 25 minus 9 from both sides. We have b squared equals to 16. Square root of 16 is b equals 4. So we know that this missing side, the x side, will be 4, right? But also, it is negative because it is on the left side of the x coordinate side, which is negative. All we do now is just find cosine theta. So we know that the reference angle over here is the theta part, and cosine is adjacent over hypotenuse, so adjacent would be negative 4 over 5. So we know that. Space. Cosine theta is equal to negative 4 over 5. But we also know that cosine in the second quadrant is negative. The next problem, we see that we have to find the cosecant of theta, right? We are given the cotangent of theta, which is negative 1 over 2, and it says that theta is in quadrant 4. So for this, draw an x and y coordinate plane. We know that this theta will be in quadrant 4, so somewhere over here. Draw a line down over here, which will form a right triangle. Right triangle. So cotangent of theta, okay, so cotangent of theta in this case is equal to negative 1 over 2, so negative 1/2. Cotangent is the same thing as cosine over sine. So cosine in this case is x, as always, and sine is always y, right? So in this case, x would be 1 and y would be negative 2. So in this case, we see that on the x coordinate plane, we have 1. It's positive because it's on the right side of the x-axis. And in this case, we have 2 would be negative because it is in the downside portion of the y-axis, which is negative. Okay? We're trying to find the hypotenuse side. All we do now is just use Pythagorean Theorem, which is 1 squared plus negative 2 squared equals c squared. So just 1 plus 4 equals c squared. You have 5 equals c squared. Take the square root of both sides. All we get is square root of 5 equals c. So we know that this side over here is the square root of 5. Okay? Drive some more room. Now it says to find the cosecant of theta. So cosecant of theta is just hypotenuse over opposite. But if you don't know that, we know that cosecant is just the reciprocal of 1 over sine over theta. Right? So in this case, that is our reference angle for theta. We know that sine is opposite the hypotenuse. So in this case, sine is equal to -2 over 5, or square root of 5. And all we said is sine is the reciprocal of cosecant. So just flip them, and we will get square root of 5 over -2. That is the answer of cosecant theta. If you don't know how to use that way, you can just use the formula that I gave. Cosecant over 1 over sine over theta. So we know that 1 over sine of theta was what? -2 over square root of 5. Okay. All we do now is just take 1 times. Instead of dividing, we are multiplying now. So flip them. -5 over square root of 5 over -2, which is still square root of 5 over -2. And that is cosine of theta. Cosecant of theta. Now moving on for the next problem, we see that for this problem that they ask us to find tangent of theta. Well, they give us that sine of theta is 1 over 2, so 1/2, and then it says that theta is in the quadrant, the second quadrant. All right, so for this, again, we drew an x and y coordinate plane, and all we do that we know that it's in the second quadrant, so something like this. Bring down to the x-axis and draw a right triangle. Okay, you know that sine, again, is 1/2 in this problem. Sine is always y over r. So for this, we know that the y-axis will be 1, and the r hypotenuse side will be 2. Again, we're going to find the x-axis for this, and all we do for this is we do Pythagorean Theorem. So 1 squared plus b squared equals c squared, 2 squared. So 1 plus b squared equals 4, minus 1 on both sides. Get b squared equals 3. Take the square root of 3, and we know that b is square root of 3. So for this problem, we know that this over here is the square root of 3. Get us some space so we can make some more space. Now to find the tangent of theta. Okay, tangent of theta. All this is opposite over adjacent. So opposite over adjacent. Okay, so tan of theta. Okay, it's opposite over adjacent. Before we do that, we know that on the x-axis it should be negative, because on the left side of the x-axis is negative. But also we know that the second quadrant, only sine would be positive and everything else would be negative. Okay, so again, tan of theta in this case is just opposite over adjacent. So this would be 1 over negative square root of 3. Let's rationalize the denominator by multiplying both sides by square root of 3. Negative square root of 3. For this, we get negative square root of 3 on top, and the bottom, all we get was just 3. So tan of theta is negative square root of 3 over 3.